Okay, question 7, last question on the paper. So a biologist introduces 100 rabbits to an island and records the size of their population X over a period of time. The population growth of the rabbits can be approximately modeled by this differential equation here, where T is time measured in 7 years. Find the population of rabbits 1 year after they were introduced. Okay, this is 5 marks, guys. It's a differential equation, and essentially you need to solve the differential equation. How do we solve this differential equation? Well, hopefully you can see it is a separable one. In fact, this is a pretty easy differential equation, guys, if I'm being honest. It's just dx dt equals 2x. So we separate it. We bring the x's to one side, so it's 1 over x dx equals 2 dt. You could bring the 2 with the x if you wanted, but it doesn't really matter. I think it's nicer to leave the 2 over here so I don't have to deal with the 2x on the denominator. Then I integrate both sides, and the integral of 1 over x dx is ln of x, and the integral of 2 dt is 2t plus c. And then I need to find x. Well, I need to find c, but a nicer way to do it, guys, if you've ever solved these with ln's before, is if you can actually, you get x first and you write it as x is equal to e to the 2t plus c, and then you write this as a e to the 2t, where c equals, sorry, e to the c is equal to a. That's because, look, if you've e to the 2t plus c, that equals e to the 2t times e to the c. So this is just a constant. E to the c is a constant, so you can have it as e to the c times e to the 2t, which is just a e to the 2t. It's just a nicer little way of doing it. Anyway, I'll get rid of this. It'll work. It'll still work if you just leave it as c, but you'll see now this is a nicer way to do that, and I'll just find a. So this is x equals a e to the 2t. So instead of finding c, I'm finding a. And the to find a, I need an initial condition. So he introduces 100 rabbits to an island. So when t is 0, x is 100, because x is the population of rabbits. So 100 is equal to a e to the 2 times 0, which is 0. So a is equal to 100. That's it. Okay. Now I'm not done, because it says find the population 1 year after they're introduced. So I need to put this back into my differential equation, or my solution. So this is my general solution. This is my particular solution. So x is equal to 100 e to the 2t, because it's a e to the 2t and a is 100. And then he says find the population of rabbits 1 year after they were introduced. So when t is t measured in years? Yes, it is. Just be careful, guys, because if t is not measured in years, you wouldn't sub in 1, you'd sub in, well, it's 1 year, so if it was months, you'd sub in 12, but it is measured in years, so I'm going to sub in 1. So at t equals 1, x equals 100, e squared, which equals, what is 100? 100 times e squared, give me a decimal, please, 738.906, 738.906, which is approximately 739 rabbits. Because he says find the population of rabbits, you don't want to leave it as a 0.9, you kind of 0.906 rabbits, obviously, so round it to the nearest rabbit. Okay, that's part A.